Hello and welcome to Groundhog Graphics. Welcome back to my viewers that are returning, and if there are any new viewers, well, I appreciate you showing up and I hope you enjoy the video. I've been doing some live programming, and I haven't done that for a few days because I'm actually trying to make a video, so this should be a lot shorter than a live. I am just trying to figure out what it is I want to do and how to do it to make videos that are quick for me and not really a time waster for you either, because like you, I don't like to have my time wasted. So I'm going to get pretty much straight to the point. This video is going to be about a program that I just wrote that will save RAM to a file or save it to a C-style character string. The first part of the video is going to show you how to use it, show you what it does, and then the last part of the video, if you're interested, we'll go over some of the highlights of some of the code. So let's go ahead and get started. So the name of the program is bsave, but the GG is for Groundhog Graphics. If you type GG bsave without any parameters, we will get instructions on how to use it. If you wish, you may pause the video right now so you can read over this. So in a nutshell, GGBSave, which I'm just going to call bsave from now on, for binary save, does basically two things. It'll either save some RAM directly to a file and you can read it into your program, or it will save it as a C-style array and you can incorporate it into your program so you don't have to have an external file. So let's begin by saving this screen to a C-style array, and then we'll run a little program I made to test it out, and they'll also view the header file that I'm going to make. So that's the file name. I'm going to go with SC and code. I wrote the program to work with an array of that name. You can put any name in here up to 7 characters. If you have a name that's more than 7 characters, it'll just cut it off. Let's see. So we're going to start at 400, which is the screen memory, and then we're going to we're going to do 400 plus 1,000 bytes. See, you can do a plus sign in here, so that way if you don't know the exact memory address where things end, that's okay, because you can do a plus sign to it and give it just a length. So I'm going to go ahead and we'll do this right now. So this is saving the entire screen as it is right now to test.h with an array that will be named scn code. Save C array and test.h. So let's go ahead and take a look at it. cd test.h. So here we are. This is the entire screen saved. Right here into an array that you can easily just take and put in your code. Also, it lets you know the number of elements in the array, so it lets you know how many bytes you saved. So there's also another option, because this right here, the formatting is set up so it's easy for you to edit if you want to edit it. Everything's nicely lined up for the most part, with the exception of the last one right here. This one must have exceeded the 40 columns, so it put it on the next row, but that's okay. Overall, everything is lined up and ready to go. You can edit it if you need to. Now, if you don't need to edit it, which a lot of times you may not, like let's say you want to save memory where you have a sprite and you want to save the sprite data into your program, you can just do a compact version of this. So let me go ahead and quit this, and let's go and do this again with a compact version. Save. Test. Oh, we're going to override it. So test dot h scn code 400 plus 1000, and I'm going to put a dash and a C. Now this will make it compact, and it'll save several lines in the source file. So there we go. So now I'm going to go ahead and open it up. Test.h. And there it is. Now it's more compact. Now that would not be very easy to edit, but if you don't need to edit it, you've saved, I'm sure, numerous lines of text right here. We probably have way less lines. I'm guessing maybe 10. Who knows? I didn't count it up. I should have thought of that. But anyway, you can get the idea. It saves quite a bit. So now let's go ahead and test it out and see if it works. So I already have a program written up. And clear this. Get test.c. Very simple program. Doesn't even require the standard input-output header, which is unusual. Very basic. All it does is just load the test.h file, and it just reads all the bytes and puts them right into screen memory. So let's go ahead and quit this, and we will. I'll compile it, and then when we're done compiling, I'll come back and I'll show you it executing. You know, I was also thinking, just in case you don't know how to compile in PowerC, to compile this, we would do cc-p for 2 disk drives. If you're using 1 disk drive, you don't use the -p. And then I would just put test.c. That's what I just did to compile this. And then to link it, I would open the linker. Test.o, and then the up arrow, and that's it. And then the output file name, I don't know if I already have this name on here or not, so test.sh. That's why I prefixed it with the @ symbol. That way it will overwrite it if it does exist. Test.sh. There we go. And then let's go ahead and run it. And we should see the same screen as we saw before when I saved it. There it is. Right there. Let's see, run it again. Test. Yep, so it saved the entire screen. Notice how fast PowerC just brings that right up too. Let's see. It's very, very quick. Alright, so let me show you another example for just a regular binary file. Let's go ahead, and I will use this program I just made. Print character set. And we go GG be save. And we will go this test.b. bin, and we will go ahead and do 400, and we will go to 500, and that's it. There we go. So now I will open up test.bin, and we won't see the exact copy of the screen because screen codes are a bit different than ASCII codes or PETSCII codes. And that's probably another video I'm going to do too, but right now just show you that there is some resemblance to it. So cd test.bin. And there we have it. So this is saved in this file, so we could just load this in our program if we wanted to. So I'm going to exit this. Now I'll just show you a few different ways we can do it. This program accepts decimal memory locations, decimal and hexadecimal. So let's see here, GGB save, and you can mix them together. Test.bin, and I can go 1024 instead of 400, and then I can do 1024 plus 256. Oh, that I didn't overwrite the file. But that's okay, because you'll see what it does then. See, it says it already exists, so it won't overwrite it. And we'll just type it again. GGB save. Test.bin 1024 plus 256. And test.bin. Actually, I have no reason to really open this. We already seen it. Okay, so this program only works under the PowerC shell. I'll take you to the website where I have it. So this is the bigsig.org website. And you just go down, you'll click on Site Index. And we will look into Commodore 64 128, go down to GGB save for the C64. And this is some instructions here, pretty much what was already in the program. And at the bottom there's a disk image, and we can click that, and that will download it for us. Now I'll also put a link in the description below for this. Alright, so let's go ahead and open it up. CED ggbsave.c. So like I said, I'm not going to go through every little detail of this program. This prints the help page that we saw earlier. I will show you a neat little trick here if you're new to C. If you use a printf and you do %s and you use the argument v for your command line arguments, if you use the 0, which is always there, that will be whatever program name it is. So if you even rename it, it will still come up as whatever you renamed it as in your text. And then, other than that, there's nothing terribly exciting here. This is f exists. If the file exists, it's just an error. When the program is done, it just prints out it's saved. Nothing special there. Convert, and now what this does is this figures out if you've entered a decimal number or a hex number. So what it does is we send a string to this function. It checks the very first character to see if it's a $sign. If it is, then it will use scanf %x, and that will save the hexadecimal number into this num variable. Otherwise, it just does ASCII to integer in the num variable, and it returns it. Then we have the sum. This allows you to add the plus sign that we did earlier. So what this does is we send the string to it, and it checks to see if the plus sign exists in the string. If it does, it has two unsigned numbers, num1, num2. It uses the convert number function we just saw above for num1 and for num2. Notice that the P symbol for plus symbol is a +1. That way, because right now the P symbol would be located right on the dollars, right on the plus sign. So we don't want that, so we add 1 to it, and that way it'll convert it, and then we return num1 plus num2. And if the plus symbol doesn't exist, it just sends you whatever number the string has in it. Just in case you're not familiar with how to take command line arguments in Power C, this is K&R style C, so all the parameters will be, the types will be listed after or below the function name, as you've already seen above. So we have argc is your count, that's how many arguments your program has, and argv are the string, is a string array of strings, and so it's an array of string pointers. So we have integer for argc and a character of string pointers, which is an array, and that is how you can take your parameters, and then you can also check to see how many parameters your program has taken. So this program here uses the number of parameters that it receives to determine if you want to save to a regular binary file or if you want to save to a C array, because the C array takes an extra parameter or two that in order to give it like the array name, the stuff you wouldn't have for a regular binary file. So if argc is greater than 4, it will assume that we are saving to a C style array. So go down here, and nothing particularly interesting. You can see memory right here is a character pointer, which was defined up here. It's a character pointer. It gets the result from the string through the sum function above, which does the conversions, and the length does the same through the sum function, because remember, if there's no plus sign, then it will just convert the numbers. So we can just have this one function to sort of do it all. And we come down here and we subtract length, which is usually, well, which will be like your end address. It'll subtract it from mem, and that will give us our actual length, which we can come down and we can use in a while loop and just keep subtracting and formatting code and putting it in the file and so forth. Another thing too is when you want a compact C array, and I said you use -C, actually you could put anything you want in there. It makes no difference. It just checks to see if there's that extra argument is there, and if it is, then it makes it compact. But just to make it make sense, I go ahead and say, put a -C. But really, it doesn't matter what you put in there. If there's 6 arguments, it's going to make it compact. And up here, every time we do an fprintf, anytime you do a write to a file, you should always check with ferror, checks the error channel, make sure that there's no out of disk errors. I'm not really checking for what exact error could come back. I'm presuming if there's an error, it's out of disk space. So that's the error message you will get if there's a problem. And this right here is all that it takes to make the C array. This bit right here. Then after this, if our arguments are not greater than 4, if our 4 equals our arguments, then we will go ahead and we will just simply open a file, check if there's an error, write the memory locations that you want to the file, once again check for an error, close it, and congratulations, you're done. And if none of those match for arguments, then it just simply prints the help. And that is it. So I will have a link to this program in the description of the video. I appreciate you guys watching. Let me know if you like the video being a little bit shorter. I really, like, I don't know. You know, I'm doing lives, I'm doing little videos, and I'm just trying to find myself on here. So, anyway, it works. Thanks for sticking around, and I will see you guys in the next one. Bye for now.